right, ladies and gentlemen. Loose notes. Let's get ready for class. So, being that we did everything on Friday, that would have been done. Let's not even worry about getting it out. If you aren't here on Friday, then watch the video. So, good. Thank you for watching it. And it becomes socially awkward when it's like, hey, what did we do on Friday? Did you watch the video? Oh, yeah, I forgot. Well, what did we miss? I watched the video. You figured it out. Huh? So yeah, what was the magic trick? I forget. Okay. I hope you all had a nice long weekend. I don't know about y'all, but I would enjoy 3-day weekends anytime they want to do with us. So that was good. Who knows what's up on my board? Java. Okay.
Java update.
All right. Well, let's not worry about that now. We'll do that later. When you want to do it. All right. Okay, so we're going to get into rewriting equations so we can, start figuring out, solving for individual variables. And if I had like two letters that are put together, like if I had A and B right next to each other, how would A and B be held together without even saying anything? Like what math operation would hold A and B together?
Multiplication.
Multiplication. If I had like A over B, what's holding them together?
Division.
Division. If I had like A plus B, obviously addition, and A minus B, we have subtraction that's holding them together. So we have to remember the opposite things. And it's still going to be like where we did the line where you have the equal sign on either side. So let's see what we can do with this. Solving for x. Okay. So subtract 8. So and what I want to do is I'm gonna try and mimic this as best I can. So I know I had started this, and then I kind of went away from it. Bless you. But I wanted to come back to it. Does everyone feel okay about that so far?
Yeah.
Okay, and then what's the next step that we go with?
Divide by 2.
Divide each side by 2. And so we find that x is equal to, reduce it, and we find an answer of x equals 2. So we had solved for x. Okay, and I know that's something that we've done, and we've done, and we've done, and we feel pretty good about it. And I had started out you doing this vertical line, then I kind of stepped away from it a little bit. We're kind of come back to it because I think it'll be easier to recognize these as we progress further and further with solving equations. So solving for a letter, a lot of times what that really helps you with is in later classes, including science classes, is sometimes you can substitute a formula into a formula. Okay, and I know that sounds complex. It really does make sciences a lot easier when you get that understanding. But when you're going to start getting to points where you're going to have to start substituting equations into other equations, which is nice. May I move off this screen? Okay. All right, so on this one, I want to solve for x. But what do you also notice is in this equation? There's a y. Okay, so 2 and x are being held together by what math operation? Multiplication. And what about 8 and y? How are they being held together? Multiplication. So what we want to do on this one is we want to get x all by itself. So I'm going to do that vertical line. Okay? Any thoughts on how I would start getting x by itself? What was the first move? Sir?
Subtract 8y.
Subtract 8y from both sides. Now here's a question. If I go 12 minus 8y, does that simplify to anything different? Or does it? No. Because they're unlike terms. Agree? So my next step, I'll have 2x still over here, because those cancel out, right? And that's going to be equal to 12 minus 8y. Or I could have negative 8y plus 12. Okay, so we're trying to get x by itself. So we're in the process of manipulating our equation to get x all alone. Okay? Is x all alone right now?
Yes. No.
No, what's with an x right now? The 2 is hanging out. How are 2 and x being held together? Multiplication. What is the reciprocal operation of multiplication? Division. Cool. So I get x is equal to 12 over 2 is 6 minus 8 over 2 is 4y. So now these two equations are the exact same thing. It's just I have one that I have solved for the letter they told us to solve for, or asked us to solve for. Yep.
And how do you do it with
Oh, we'll get there. We'll definitely get there. I like where you're going. We're going to get there, though. Make sense? And does it make sense that I'm doing that vertical line? That vertical line represents the equal sign. What we do to one side of the equal sign, we have to do the other side. And again, that was something that we had started with in the beginning of the year, and I kind of went away from it a little bit. But now we're reintroducing it. So I think it's easier to see what's taking place up here. Okay? So what's the big difference between the two? Well, really nothing. You're understanding that you have like terms and you don't have like terms, and when you're adding and subtracting, like terms have to stay as adding and subtracting problems. If you're multiplying or dividing, like terms can be combined. But we'll get there. Let's see. Can I move off the screen? We can rewrite an equation to get rid of a variable. We can rewrite an equation to get a variable alone using the same rules we use to solve singular variable equations. So when we just had x by itself, or m by itself, or y by itself, or whatever letter by itself, we're doing the exact same work up here, but it's just one of those you have to understand is we're trying to get the letter by itself. We're not trying to, combine things that won't combine. And then why do we want to do this? And this right here, this is a lot of times people ask, but it really comes down to you can take equations and plug them into each other. Okay, it really will make science courses, and maybe not the science course you're in right this very second, or maybe not today in science, but as you progress through science, one of the things that you start realizing that makes science more easy, in my opinion, is, oh, I know I can take this, plug it in here, I can substitute this in here, I can substitute this in here, and all of a sudden things break down and work out nicely. It's an input-output thought process. It works with computers. Okay, does a computer take something that you put into it and spit something else out? And it should, as long as it's working appropriately and you're doing things appropriately. And so this goes along with programming codes and things like that. And I don't need to get into the schematics of programming. I had many years ago taken C programming for 3 semesters, and now it's programming. The languages have changed a little bit, but I do recall when there was something called a punch card coming out, which was good for about 8-bit of data. So a line of zeros or ones with only 8 of them. And a 0 or 1 represents on or off with the computer. And your computer essentially still works the same way, but your phones are more incredible of a processing computer than when we put, if you were to take all the computer processing stuff we had when we put a man on the moon in 1969, your phone has way more processing power than any of those computers that are on the Earth and on the rocket to get the men on the moon. So you think about that. I don't know if you've ever been to Cape Canaveral or Houston for their stuff, but you go and you look at some of those first things that we put men into space with, or women into space with. It was basically a soup can. I can't put it any other way. That's all it was. It was, here it's pressurized. We're gonna strap it to a rocket and go boom real fast. Yeah.
When I was in Melbourne, Florida, I don't know if you know, you could see like Cape Canaveral and some of their launches.
Yeah.
It was pretty cool.
Did you ever see a nighttime launch? I was in Florida I guess it was 1991, and it was just a satellite that they were launching. It was a nighttime launch, and we went, and we were opposite of, across that bay watching it, and it was like daytime. That's how bright it was. It just lit up everything. This is amazing. So it is a neat scenario. Yeah.
Wait, was that launch in Florida or Houston?
Florida.
Oh, okay.
Mission Control is in Houston.
If it was in Houston, I was wondering how it would have.
No, in Florida. When I was in Florida, the launch was in Florida, and I imagine anywhere within about 10 miles you could see it very clearly. But it was amazing. I really do like the whole anything in outer space. I think it's a fantastic thing. There's definitely inventions that have come out of because we put people on the moon and we've put things into deep space and landed things on Mars and had things crash into Venus and other things. There's so many things that have come forth to change our lives. The big one really is how cell phones work. Heck, there was times that my grandmother, I remember this. There was 8 homes that were on her street in New Jersey, and they had something called a party line for their phone line. And so if somebody would call their phone number, it was good for all of the homes up and down the street. So everyone's telephone that was connected to the wall rang. And so if you answered it, and it's like, hey, I need to talk to Billy, that's the neighbor 3 houses down. So it's like, okay, hang on. You'd run down, knock on the door, hey, Billy, pick up the phone, and then you'd come back to your house, hang your phone up, and Billy would be able to talk to you. And that's as crazy as it is. I mean, that's what it had been, which was a great innovative thing at the time, going, oh, okay, if one phone works for 10 people, this is fantastic. Which obviously we're in a much different place now than we had been. And that, you say was that a long time ago? That was 40 years ago. So, yeah.
Wait, but if you went and knocked on the door
and they weren't home, then you would take a message, and you would then walk the message down. Yeah, I mean, there was no answer machines, bless you. It was rotary dialed phones. It was crazy.
Wait, so if you went and knocked on their door and they were there, you tell them to pick up their phone. Why can't you just talk personally right there?
Well, you didn't have the phone with you. It was connected to the wall. Your phone was hanging on your wall in your kitchen.
Couldn't you just talk to them face to face?
No. Like, let's say your friend that was 10 miles away was calling you. Your neighbor could answer the phone, and then they'd have to go down to your house and say, hey, pick up your phone. The phone's for you. Like, the phone would have rang in everybody's house that was there, the 8 neighbors. So, I mean, it's so weird, and it's weird to think about that. It was a different time. When I first moved to Arizona, if you were in Tempe, Arizona, you could call my parents' house by dialing 1202, and that's it. And my parents' phone would ring if you were calling from Tempe to Tempe. Now, if you were in any of the Phoenix suburbs that were on the east side of Phoenix, so if you're in Phoenix, on the east side of Central Avenue, or Chandler, Gilbert, Mesa, Tempe, or not in Tempe, you would have to dial 839 and then 1202. Now, if you were on the west side of Phoenix or Central, or in Glendale, or any of those, you had to dial a 1-839-1202, and then you get a line. But I mean, we've changed so much, and a lot of it is attributed to because of our things that we've done with outer space, and a lot of things that with the cell phones and how that communication takes place. So it is pretty fascinating. So here's a whole bunch of things. Where could you plug things in? Like, you guys and girls probably recognize E equals mc squared. Okay, that's energy is equal to the weight of mass times the speed of light squared. If you want to figure out how much energy something has, you weigh the mass of it, and then you take the speed of light and you square it, and you multiply that times, and that's how much energy a particular object, any object, would have. It's a universal thing. You could figure out the speed of light if you knew the energy, and you divide it by the mass and should square root of it. So there's different things you can do to manipulate these equations around. And what's neat is anytime you have equations like PV equals nRT, this is the universal thing for pressure, volume, and temperature, and so that's a universal thing for your it's pressure and volume. So it's definitely used for in your science classes later. pH deals with natural logs. pH is talking about how acidic something is versus how basic it is. Looks like they ran out of ideas. They had to do PV equals nRT twice, and E of MC squared. So who knows? Fahrenheit is equal to 1.8, and you can convert those things. So these are just different places where we could plug things in. Look at that. We're just guys on. Looks like he's on chalkboard, but move off that. So solve for y. We want to get y all by itself. So let's say, show me your hand if you know what that first step is going to be. If I want to get y by itself. Yes, ma'am. Subtract 2x from both sides. I like it. Now, can I ask you a question? Can 24 and 2x combine together to become something different? No, it just becomes that. So that cancels that. So it gets me y equals negative 2x. And 24 is positive or negative? Positive, so we put a plus sign there. Someone might ask, could I have 24 minus 2x? Absolutely. Okay, so what's the difference? Nothing. It's just how you rearrange it. So that's pretty straightforward. There was only one little step you had to do on this because y didn't have anything attached to it. May I move forward? Solve for y. Okay, let's let you guys get a start on this. I want to get y by itself. Now y is attached to a 3 by multiplication, so something has to take place. But let's get y by itself on this problem. See if you can figure this out. And I like the vertical line. Some people don't see the vertical line right away, but I think it's a good thing. If you use it, if you don't see it right away, that's okay as well. Gentry, can you tell me that first step? I'm with you. Subtract the 3x from both sides. All right, so if I do that, that cancels that. Do you agree? Everyone agree? So I'm going to rewrite the whole equation. 9 minus 3x. Okay? John, I want to get y by itself. What should I do to everything?
You should divide by 2.
Yeah, because 3 and y are being held together by multiplication. The inverse operation is division. So I'm going to divide that by 3, that by 3, and that by 3. And when we solve that, y equals 3. And that just reduces, right? And then that becomes 1 over 1. So that's minus x. Is this and this, that's a y. Are those the same thing? Mm-hmm. Notice how the signs work. Is there a plus that's here that we need to put? No. Can we? Sure. But these are the exact same answer. Which one do I want? You pick. On a multiple choice test, I'll have one of those. I won't have both and say, all right. Or if I do have it on multiple choice, I'll say, pick all that apply. Could you have more than one answer on a multiple choice? Sure. You know, A and C might be correct. All right. Ooh. Little different. A little different. We want to solve for y. Madeline, can you tell me what that first step might be right here? You think? Yeah, subtract the 3x. Good job. All right, so I'm going to subtract that from both sides. And that's going to leave me 1/2 y is equal to negative 3x plus 6. Or I could have had 6 minus 3x, but I have to pick one or the other. Okay? Yeah.
Could you multiply by 2 next?
I like it. I like it. Multiply everything by 2 next? What do you guys think? I like it. Now, 1/2 y. If I multiply everything by 2, that means that the 1/2 times 2, the 2's cancel out. So if I multiply, so technically this would be multiplied by 2 over 1, and this would be multiplied by 2, and this would be multiplied by 2. That cancels, so it leaves me just what over here? Y equals 2 times negative 3x?
6x.
Negative 6x. Wash your signs, okay? And then 12. And we have now solved for y. Y is all by itself. Feeling okay? Am I going too fast? So a couple things to think about that are coming up, and I'm not done yet, but we will, a week from today, have a test. We're going to do more of this rewriting stuff Wednesday and Thursday, so tomorrow and the day after. And then we have a practice test we'll do. And then there'll be a small portion of the test on Schoology. And then there'll be stuff on Monday, which goes along with the test. And then Tuesday we'll actually take the test. Sound good so far?
How big is the test?
Huh?
How many points?
700 trillion. So I thought about making it in the billions, but I thought trillion was better.
I think I like
Trillion. Yeah. Just because, you can't get the number to fit.
Yeah.
And I mean, if you miss like 50 points, you still have like,
A plus.
999 billion points. All right. Let's see what else we got. Solve for y. Wait, hang on. What's different about this problem than,
To combine the
I have some like terms, possibly. Let's see, on the left side I have 4x, 6y, and a negative 11. Are there like terms on the left side at all?
No.
No. What about that right side? I have 2x, 4y, and negative 9. Is there any like terms over there?
No.
No. So I have like terms, I agree. Sometimes they're on one side or the other. So I have nothing on one side that I have to combine right away. So let's see what we could do here. Let's put our... You want to go... What are we solving for? We're solving for y, right? So I had a shout out of subtracting 2x from both sides. And some of you might be looking at that going, but shouldn't I have added 11? You got to start someplace. So you have to start trying to undo the problem. Okay, so on this particular problem, subtracting 2x might be a good place to start. Is it the 100% most appropriate place? Yes. Is there another 100%? Yes. So this becomes 2x plus 6y minus 11 is equal to 4y minus 9. What are we trying to solve for? Y. Do I still have a y on both sides? I do. We heard someone say adding 9. That might be a good idea. I could add 9 to both sides. So again, we're just trying to undo these problems a little bit. That gives me 2x plus 6y. Is that minus 2? Okay. Then I get 4y. Do I still have y on both sides? Is y on both sides still? Everyone agree? So now we have to say, let's start moving the y over. So still kind of having this thing go down here. Let's see. Subtract 6y. Subtract 6y. That and that are gone. I'm left with 2x minus 2 is equal to, what does this come out to? Negative 2y. I like it. Is y all by itself yet? No. What do I have to do to everything? You're real close. Negative 2. Watch those signs, okay? Divide that by negative 2. Divide that by negative 2. Divide that by negative 2. And remember, when you divide by a negative, it goes and starts changing signs. So what is this?
Minus X.
Good. Didn't forget the sign. What is this?
Plus 2.
Oh, you're close.
Positive.
Yeah, I agree with plus. Plus 1. Good. Everyone get that? Why is that a plus 1? Negative over negative is positive. 2 over 2 is 1. And then what is this one? What does this become? Now, a lot of people get frustrated that, well, I solved for y, but it's on the other side. Could I rewrite this to look like this? Are all the signs the same? It's positive y, negative x, positive 1, positive 1. All the signs are the same. I can flip-flop it. It means the same thing. Which one's right? They're both good. Yeah. X minus 1? Not x minus 1, but 1 minus x would work. So if you had this, this works. But watch your signs. You're saying x minus 1. That means you have a positive x. And it should be negative, and a minus 1 should be positive. Huh. Can I move on? Is there any more? Almost done? I have a 2 more? Oh, shoot. Go ahead, stop drinking Diet Coke. Ooh, F equals ma. Force equals mass times acceleration. That kind of sounds like science. times acceleration. How are M and A being held together? Multiplication. What undoes multiplication? Division. If I wanted to get A all by itself, what would I have to do to both sides? Divide by each side by A. Okay, so I can M. I'm sorry. Oh, you guys are awesome. You guys are keeping me as a good teacher. I appreciate you paying attention. That cancels that. So A is equal to F divided by M, or you could write it like this. Both those answers are correct. I like them both. Okay? And again, realizing how things are being held together and undoing it will help you in math courses and science courses later on. And again, substituting things in, pretty good. Are there predictions that we can make using math?
Yeah.
Sure. Okay, are they always right? Does anybody know a job out there that they use an awful lot of math and science, but they're not always right?
A math teacher.
Oh, good call. Well, yeah.
Aerospace engineering.
Aerospace engineering? Yeah, you want to know what a big error was many years ago? I don't know if you guys were born yet, but the first time we had sent we were sending one of those Mars rovers to go to Mars. You know what the big error was? All of the stuff we were doing here on Earth was the metric system. All the stuff that the rocket ship was reading was in the English system, meaning feet per second or meter versus meters per second. Rather than miles per hour as in kilometers per hour. Guess what that thing did? It either crash landed on Mars and they couldn't figure out what the heck happened to it, or it bounced off Mars and they can't figure out where it went. Kind of a big error?
Bounced off.
Was that? If it crashed into Mars, it's probably pulverized. But, they probably could. The thing is, in order for a radio signal to get back to Earth, it's traveling at the speed of light. For Mars, it's about 24 minutes. And it's 24 minutes for a signal to come back. So if you sent a signal to say, hey, do this, and then it sends back, you're talking about 48 minutes. Because it has to go there and then come back to let you know that it happened.
That's
So,
pretty quick though for the distance.
yeah, no, I agree. I mean, that's kind of how the speed of light works, though. So that's, fantastic. But, you think about it. If you, there's a lot of stuff that could happen where you're sitting there at mission control going, okay, we sent the signal. Okay, 48 minutes. All right, I might as well go get a bite to eat and come back. I mean, because you could wait a long time. And, further out in space you get, it takes a lot longer to get there. Anyone know how long it takes the sun from the light to get to Earth? 8 minutes. That's traveling 93 million miles. So where you're seeing the sun up in the sky, now don't stare at it, but the sun that's in the sky, that's where it was 8 minutes prior to where it had been. So that's kind of weird to fathom. So last thing, let's see. There, maybe that. P equals 2L plus 2W. This is a math equation. Anyone know what this one does? No, I like it. I do agree with pressure's P. Precipitation, yeah. It is perimeter. This is how you find the perimeter of a rectangle. You have 2 times the length and 2 times the width.
I thought that was 21, not 2.
Oh, no, it's 2L. Okay, so we want to solve for W up here. So we want to get W by itself. So I'm going to subtract 2L and 2L. So that's P minus 2L is equal to 2W. And then what? Divide everything by 2. So I get P over 2 minus, does that reduce to L? Yeah, because I could do that. And that's W. So the answer here, W is equal to P over 2 minus L. Do what I can. That's a cursive L. For those of you who hadn't seen cursive before because they stopped teaching it in elementary school. You ever want to see something amazing, go help out in a kindergarten class and tell a kid to write their name, and you watch the dexterity of these kids holding a pencil or a crayon. Like, okay, I need you to write your name. Okay. What the heck are you doing? I'm going to write my name. I thought you were dancing or something. Hey, I'm there. We done? we done?
Yay!
Oh, yeah. All right. Oh, man, that wasn't bad, was it? All right, so today is Tuesday, right? And we are at the 6th. September the 6th. Let's see. Worksheet number something. You have a birthday coming up? Woo!
Is it 10?
I think it's 10, yeah. Is that page 31, 32?
How about let's not have to work tonight?
Nope, we're going to. All right, so worksheet number 10, which is page 31, page 32. If you wanted anything to reference in the book that you all checked out from us, this goes along with section 1.5 if you needed an extra thing to take a look at. But it looks like you have probably about 18 minutes. So why don't you get a start on it? I'll wander around and help you, and we'll go from there. Let me just get the video saving.